Every mass or object has a gravitational field around it that causes other masses to accelerate towards it. A bigger mass causes a bigger acceleration, so smaller objects like a person or an apple don't cause any noticeable acceleration at all. It's only in bigger masses like planets, moons, or stars that cause these noticeable gravitational fields. On Earth, when you drop an object, it has an acceleration of 9.8 meters per second to the -2. So this means that the gravitational field strength on Earth is 9.8 newtons per kilogram. This means that there is a force of 9.8 newtons pushing downwards on every kilogram of mass. All different planets have different gravitational field strengths, and you'll get given these values on the datasheet, so you don't need to worry about memorising them. Some things to note is that the Sun has a massive gravitational field strength because it is massive, and the Moon has a much smaller gravitational field strength because it's much smaller. Of all the planets in the solar system, Mercury and Mars have the smallest gravitational field strength, and this is because they're the smallest planets. Jupiter has by far the largest because it's the largest planet. So, what's the difference between mass and weight? Mass is the amount of matter in an object. It stays constant no matter the gravitational field because the amount of stuff something is made of is not going to change. Weight is the downwards force caused by gravitational field strength. W equals mg, where weight is the W, m is mass, and g is gravitational field. This makes sense because we know that weight is a force, and we know that g is the force pushed on every kilogram of mass. Astronauts collect 2 kg of moon rocks. What is the rock's weight on the moon versus on Earth? So, let's start with on the moon. On the moon, W equals mg. The mass is 2 kilograms because it's not going to change, and our g value is 1.6. This gives us a weight of 3.2 newtons. Next, let's look at on Earth. W still equals mg. Our mass is unchanged, still 2 kilograms, but our g value is 9.8. This gives us a weight of 19.6 newtons. You'll notice that weight is measured in newtons, meaning it is a force.